Hello guys, welcome back to learning microcontrollers. In this video, I'm going to show you how we can use AND and OR gates with a PIC microcontroller. I will also explain AND and OR gates to you, a basic explanation. So let's get started. This is our AND gate. It has two inputs, A and B, and one output. It is basically a binary multiplication. Output is only 1 or on if both A and B are either 1 or on. So only 1 if both A and B are 1, else it's 0. Its circuit is in series in case of circuits, like two switches in series, switch 1 is A, switch 2 is B. If both of these switches are on, only then LED will turn on. Now in case of OR gate, this is our OR gate. It has two inputs, A and B, and one output. But in this case, it is a binary addition and output is only 0 if both A and B are 0. It is a parallel circuit like this. Switches are in parallel. If one of these switches on, LED will turn on. If both are on, LED will still turn on. LED is only off if both are off. Now let me explain this further. Now in terms of circuit for the AND gate, this is our LED having two pins. One is power and one is ground as usual. You connect one ground pin directly with the ground. Another pin, we connect two switches in series, switch 1 and switch 2. Now I turn off one switch, turn on one switch, LED does not turn on. It means that it's an AND gate. Now when I turn on the second switch, only then the LED turns on. It means LED will only turn on, that output will only be 1 in case both A and B are at 1. Now for OR gate, this is our LED, this is a ground as shown previously. This is our first switch, and in the parallel this is our second switch, and this is our connection to the LED. Now I turn off the first switch, LED turns on, and when I turn off the first switch and turn on the second switch, LED still turns on. So as you can see, if either of the switch is on, LED is on. So it is an OR gate. Now let me show you the Proteus demonstration. Okay, this is our Proteus. Let me zoom it in. Click on ISIS. I had opened it already. Click on keywords. Here you select PIC16F877A. Here we go. Place it somewhere. I place it here. Now we need two buttons. SP, ST will do fine. Okay, this is our SP, ST switches. We use a port B. Connect one here. Connect the other one here. Okay, first this is our AND gate, and this will be our OR gate in parallel like this. Now we connect the button in you can say 0 configuration, that when the button will be pressed, a 0 will be sent. For that we will need a resistor, 10k resistor, or you can write res40 resistor, and this is our resistor. Place one here, one for each button. Here we go. Now we do the connections. Connect here. This is for series. Connect one end of all the you can say all the resistors together. This will be our common 5 volt to the buttons. Here we go. Okay. Now connect other end of all the buttons to the ground like this. Connect them to the ground. This end will be connected here. Okay, so and this end will go here. Okay, now this is our, you can say, the first part. These two are our series, parallel ones, and these two are our in series. Now let me give the voltages. Go to terminal mode. Here you have power. Click here. Give 5 volts, or you can say power here for simulation. Go back, take a ground, you place it here and connect other end here. Now from this end you take your outputs, that is for the first button, that is for the second button of our, you can say, parallel connection. And now for the series connections, I take B2 and B3. B0 and B1 are for parallel connection, B2 and B3 for series connection. Now we go to our mikroC for PIC. Here we go. This is our mikroC for PIC. Go to start page, close any remaining projects, go to new project, click on next, any but and or gate. I'm using PIC16F877A, 20 megahertz crystal is fine. Click on next, 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 and finish. Okay, let's zoom it in. Okay, first of all, we initialize the port B as input because buttons are at input. Port B is equal to 0 into FF. It will be declared input. Give some initialization delay. 100 millisecond will do fine. Now give the initial state. B dot port B is equal to 0 into FF, because initially our state is 0, but our button is in the 0 configuration, that when the button is pressed, a 0 will be sent. So initially the port must be at 1, else they will already be activated. Give some initialization delay. 100 will do fine. Okay, that's good. Now we need an LED as well. For the purpose of demonstrating the output, we use an LED at some pin of, okay, we use a D7 pin here. Go back to go back to selecting components, click here, component mode, write LED. Okay, in the LEDs, you have many LEDs. Go down, down, down. Okay, these are the one we can use. I use a green one, LED BRG green. Okay, I place it here, connected to pin D7. This will be used for the purpose of demonstrating output, connected to the same common ground. Okay, that's great. Now we initialize this pin as well. Go back to mikroC for PIC. Zoom in. It is Proteus D dot F7 equals to 1. It's an input pin. Oh, sorry, an output pin 0. LED is at this pin. So we give our initialization delay. 100 will do fine. Now we give it its initial state, which must be 0. Port D dot F7 equals to 0. Initially LED must be off, so it's 0. Now we give initialization delay. Now we can go to our forever loop. We have the LED, we have the buttons. Okay, this is it. First of all, we do programming for the AND gate. AND gate. Okay, here we write if port B dot F0 equals to 0, and this is AND operator here, double AND port B dot F1 double equals to 0. Now close both brackets like this. This is the syntax for using AND comparator in the PIC microcontroller using mikroC for PIC. Now what should happen, that this LED should turn on. So we write if this happens, only then this LED turns on. Like both the buttons and 0, F0 and F1, we are using AND operator. If this configuration happens, only then the LED turns on, else LED is off. Port D dot F7 equals to 0. Remove this delay, 0. Okay, that's great. Now for the OR gate. Okay, here we go, OR gate. Okay, this is for the OR gate. Now if port B dot F2 double equals to 0, or for OR we have this bar, or port B dot F3 double equal to 0. It's a dot. Then close both brackets first. Give it up. Oh, sorry. Close the brackets using this and this. Okay, now the brackets are closed. Now what should happen is that LED should turn on. Like in previous case, LED will turn on. For 100 millisecond, we make it 500, and here too we make it that LED will turn on for half second, then it will turn off. Okay, and in else, like previously, LED is off. You copy paste it, else it's off. So this is our two loops in one program. Build it. See. Okay, we have a problem here. Delay. Okay, we had used wrong brackets. Use these semicolons. Shift plus again, because we copy pasted them. So it's a error with all. Again build. Okay, same problem. Again build. Same problem because we copy pasted them. Okay, now the code is built successfully with all the debuggings. Okay, now we go back to our Proteus. Name of the code is and an OR gate. Go to Proteus, double click on this microcontroller, set your crystal 20 megahertz, select your programming. I saved it at coding. Here we have and an OR gate. Here we go. This is the code. Okay, click on OK. Now I run the code. Let me zoom it out a bit. There's too much inside. Okay, I run the code. I click on run. Okay, now the simulation is running. You can see LED is off. Initially LED is off. As seen in the programming, LED must be off. Now I first of all go to the AND gate and I switch off one button, that is this button, and see what happens. See, LED didn't turn on. Now I turn off the second button. Now LED is on. As you can see, it's on. I switch off one button only. See, it's off. It's an AND gate. You can see now it's on. Now I do the opposite. I turn off this, turn on this button. LED is still off. When both the buttons are on, only then the LED is on. That is the AND gate. When both are 1, only then it's 1. So as you can see, this symbol here represents the AND gate in mikroC for PIC. Now let's go for the OR gate. Okay, turn them off. Okay, LED is off. Now this is our OR gate in parallel. I turn on this button only. See what happens. LED is on. All through the other one is on. So, but now I turn this one off and I turn the other one on. See, the LED is on. Okay, see, if I turn on any button, any of these two buttons, LED turns on. See, if I turn on both the buttons, still the LED is on. It means LED is only off when both the buttons are off. So this is an OR gate. In case of OR gate, LED is only off when both are off. Like only output is 0 when both the inputs are 0. So guys, I hope you guys learned something from this video. Thank you very much for your time. So have a nice day until the next video. Goodbye.